Hi everyone, this video is all about the quadratic formula. We're going to do 5 examples that get us into every case when to use the quadratic formula, and at the end of the video I'm going to show you why it works as we derive how the quadratic formula actually came about. So the quadratic formula gives us solutions to the equation ax squared plus bx plus c equals 0, where a, b, and c are any real numbers. The formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And there are lots of fun songs to remember that if you need to remember that, but most of the time your teacher will give that to you so that you have that available on tests. Let's look at the first example and use that quadratic formula now to solve this. Example 1 says this: solve for x squared minus x minus 1 equals 0. Now the first thing to recognize is that you have to have it equal to 0 to use the quadratic formula. But the other thing to recognize is that if you can factor something, we're going to go ahead and we're going to try to factor that because factoring is generally easier. Now this is a simple trinomial, it looks like, and so we are trying to factor it in that way. So we're going to try to find two numbers that add to the middle term, that's a negative 1 in front of the x, and multiply to the last term, negative 1 at the end. Now factors of negative 1, the only factors of negative 1 are 1 and negative 1, and those add to 0, so those will not work. So in this case we have to use the quadratic formula because it's not factorable. So we go ahead and we pull out the equation x equals negative b plus minus the square root of b squared minus 4ac all over 2a. So before we start subbing these numbers in, it's important that we recognize what a, b, and c are. Now a is going to be equal here to 1. If there's no number in front of the x squared term, it's like there's a 1 there. B, as we already discussed, is negative 1, and c is negative 1. So now I sub those into the equation. Negative 1 plus or minus the square root b squared, so it's negative 1 squared, minus 4 times a is 1, times c is negative 1, all divided by 2a. Now the a term is 1, so 2 times 1 in the denominator. It's also important that you make sure that that square root is over all the terms there. Otherwise, if you didn't show it all over all the terms, it really technically wouldn't apply over all the terms, but it should apply to the entire of b squared minus 4ac. So now what we're going to do is we're going to simplify this a little bit. So negative 1 gives me positive 1, plus or minus the square root, negative 1 squared is 1, and then negative 4 times positive 1 times negative 1, that's a positive 4. Look at the number of negative signs. If we have two negative signs, it makes it a positive. So this is adding 4 to the 1, and then we're going to divide by 2. So taking this one step further, we get 1 plus or minus the square root of 5 all over 2. And that is actually our exact answer. We could list this as 1 plus root 5 over 2, or x equals 1 minus root 5 over 2. And so what we could do is those are actually the exact answers. So sometimes your teacher might ask for an exact answer, and if they do, those are your two answers. But if they're asking for a rounded answer, then we could round this and we get x is approximately equal to 1.618, or x is approximately equal to 0.618. And so one thing that's interesting here is this number 1.618 is the golden ratio. And so if you're interested in more about this, this is something we see all the time in nature. There's a video linked in the description below that you can look into the golden ratio further. But if you want to continue with the quadratic formula, continue watching this video and check that out after. But it's a very interesting topic to look into and something that's very aesthetically pleasing to the human eye. Now notice here that this gives us two solutions, and this is almost always going to be the case. And we're going to look at cases later in this video where if I have this thing that I'm adding or subtracting, this square root of b squared minus 4ac, if that is 0, then it's only going to give us one solution. But anytime that that value ends up being positive, then we're always going to get more than one solution. We're going to add that to the negative b over 2a or subtract that to the negative b over 2a. And so usually you'll have two solutions. But the last two examples are going to look at situations where we do have either one or then one other case where maybe that square under the square root is negative. So we'll see that in examples 4 and 5. Example 2 says solve for x. 2x squared plus 8x minus 10 equals 0. Now again, because it's equal to 0, we can solve for x. And so what we're trying to do first here is we're trying to factor this. Now we can common factor a factor of 2 out, and we're left with x squared plus 4x minus 5. And so what we do at this point is we divide both sides by 2, and because it's equal to 0, 0 divided by 2, the 0 divided by 2 is still 0. So we get x squared plus 4x minus 5 equals 0. And so you might think, well, we've common factored it. We've factored as far as we can. Now we have to use the quadratic formula. Well, we're going to keep trying to factor this. And if we can, then we don't have to use the quadratic formula at all. So we're trying to find two numbers that add to 4, multiply to negative 5. Those two numbers are 5 and negative 1. And so we can go ahead and we can write this out as x plus 5 times x minus 1 equals 0. And then we say, well, that means that either this is equal to 0 or this is equal to 0. One factor or the other has to be equal to 0. We have two factors, one in brackets, the other in the other set of brackets. And so x plus 5 equals 0, or x minus 1 equals 0, and we get x equals negative 5 or x equals positive 1. Now, that was factoring. You told me this video is about the quadratic formula. We are going to look at this using the quadratic formula, but I want to make sure that you know how to go about factoring something so that if you run into that case, you don't have to use the quadratic formula, which is a little more tedious. And so if you do need more practice on factoring, check out the video in the description about factoring. But let's continue on now looking at the quadratic formula. How would you solve this using the quadratic formula? Well, there's actually, you could do it in a couple of different ways. You could have common factored out the 2 first. And if you did, what you would have had is you would have had a equals 1, b equals 4, and c equals negative 5. So going ahead and subbing them into the equation we've been talking about, we're going to go ahead and sub all those values in, just plug them in and chug. I like to say plug and chug. We plug them in and chug it out until we get the answer. Now we get negative 4 plus or minus the square root of 4 squared minus 4a times c. So 4 times 1 times negative 5, all divided by 2a, 2 times 1. So x is equal to negative 4, and we're just going to simplify what's under the square root. We have 4 squared, which is 16. And then notice it's negative 4 times 1 times negative 5. It's a positive again because we have two negatives. So we're going to add 20, and then we're going to divide by 2. Now, it's important to keep in mind here too, if you had put a positive 5 in for c, you would have had 16 minus 20, and you wouldn't have been able to get an answer. And so it's very important that we get the a, b, and c values correct, because those can lead to very different results if we don't. In fact, in that case, it wouldn't have even worked. Anyway, let's go ahead and continue to simplify this now. We get negative 4 plus or minus the square root of 36, all divided by 2. Well, we can take the square root of 36. That's a whole number, so it's plus or minus 6 over 2. And so we get x equals negative 4 plus 6 over 2, which would be equal to 2 over 2, which would be equal to just 1. Or we would get that x is equal to negative 4 minus 6 over 2, which would be equal to negative 10 over 2, which would be equal to negative 5. And so we get the same answers we got before, the negative 5 and the positive 1, by using the quadratic formula. Now, I did say there would be a second way to get the same answer. And so let's see actually how that would work. If instead of using the x squared plus 4x minus 5, if instead we use the original equation without common factoring anything out, we would have had a equals 2, b equals 8, and c equals negative 10. And so there's our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we go ahead and we substitute those values in. So negative 8 plus or minus the square root of 8 squared minus 4 times 2 times negative 10. And we're going to divide all of that by 2 times 2. So x equals negative 8. We're going to add and subtract the square root of 64. And then 4 times 2 times 10 is going to be 80. And because we have two negatives, that means we're going to add that. We're going to divide that by 4. And so x equals negative 8 plus or minus the square root of 144, all divided by 4. So that's going to give me negative 8 plus or minus 12 over 4. So now that goes to my two answers. So the first answer is x equals negative 8 plus 12 over 4. Well, that's just going to be equal to positive 4 over 4, which is 1. And the other solution is x equals negative 8 minus 12 over 4. Well, that's going to give me negative 20 over 4, which is going to equal negative 5. And we have our two answers again, negative 5 and positive 1. So regardless of whether or not you factor it or use the quadratic formula, they will all work. But I think you'd agree with me that if we can factor it, that was the easiest way to do it. By common factoring, that gave us just some better numbers to deal with there. And then we could have done it the last way, but that was the most inefficient and trickiest way to do it, just leading to more mistakes because you're dealing with some bigger numbers. Example 3 says determine the x-intercepts in the vertex of y equals x squared plus 10x minus 37. At first glance, this might look very different than the questions we've just done, but I want to show you why we've been doing the questions we've just been doing and how this actually plays out with parabolas. Because what we ultimately have here is we're trying to find the x-intercepts to begin with, and the x-intercepts are just found when we let the y value be 0. And if we let the y value be 0, well, that happens along the x-axis you can see on the grid there, then that means that we get 0 equals x squared plus 10x minus 37. And so now that looks very familiar to us. That's something that we've looked at in the last two examples. So we go ahead now and we try to factor that if we can. We want to factor it, and if we can't, we have to use the quadratic formula, but factoring is easier. So let's go ahead, try to find two numbers that add to 10 multiplied to negative 37. Negative 37 is a prime number, so the only factors are 1 and 37, the 1 being negative because it adds to a positive. That does not work, unfortunately, and so that's not factorable. So we have to use the quadratic formula now. So we go on to the quadratic formula, making sure that we have very clear signs that are correct and numbers for A, B, and C. So A is going to be 1, B is going to be 10, and C is going to be negative 37. So x equals negative 10 plus or minus the square root of 10 squared minus 4 times 1 times negative 37. All of that divided by 2a, 2 times 1. Gives me negative 10 plus or minus the square root of 100 plus 148. Negative times negative makes it a positive again, and 4 times 1 times 37 is 148. And we're going to divide all that by 2. So negative 10 plus or minus the square root of 248 divided by 2. Now what I could do is I could put that in my calculator and simplify that and get a rounded answer. But I could also get a better exact answer as well. So watch how I do that. What I'm going to do is I'm going to represent the square root, the square root of 248, as 4 times 62. I'm trying to take a perfect square out of the 248 so that I can factor it out of the radical. I'll show you how that works here. So this becomes x equals negative 10 plus or minus the square root of 4 is 2, so I can have that out front, and then I'm still left with the square root of 62, all divided by 2. Now what I can do is I can also common factor a 2 out of the numerator. And if I do that, take a 2 out of here, I've got negative 5 plus or minus 1 times the square root of 62. I don't need to write the 1 there, all divided by 2. Now the reason I did that is because now I have a 2 in the numerator and a 2 in the denominator, and I've common factored the 2 in the numerator, so it cancels out with the 2 in the denominator. And so what this becomes is it becomes exact answers of x equals negative 5 plus root 62, or x equals negative 5 minus root 62. Now that doesn't make a lot of sense as far as the graph is concerned, so that's where we do want to put it in our calculator and figure out what those approximate values are. So this is a 2.874, and if I do the other one, negative 5 minus root 62, I get negative 12.874. And those are my x-intercepts. So what am I going to do with those? Well, I'm going to put them on the x-axis. I'm going to have to go up by 2's here in order to get this to fit. I need to fit almost negative 13 on the negative side. So I'm going to go up by 2's on both the positive and negative side so that the scale is consistently spaced all the way along. It's not good if your scale is going up by something different at one point than other points. You want to always go up by the same scale all the time. And so negative 12.874 is going to be somewhere around there. Positive 2.874 is going to be somewhere around there. And those are my x-intercepts. Now what about the vertex? Because it also was asking about the vertex. Well, the vertex is found by adding the two x values together and dividing by 2. It's the average of the two x values, as it should be because of symmetry of a parabola. So I take my 2.874, I add that to negative 12.874, and I divide it by 2. And what I get is I get negative 10 over 2, which is negative 5. Now you might think, is there another way to find the x value of the vertex? Well, the other way to find the x value of the vertex is actually from the quadratic formula, because what we have is we have this negative b over 2a, and then we're adding and subtracting that square root amount that takes us to one side of the vertex, and then we subtract it, which takes us to the other side of the vertex. Equal spaces on each side of the vertex means that that negative b over 2a is also going to be the x value of the vertex. So if you wanted to do it that way, you could have said negative b, well, that's negative 10, over 2a, a is 1. Well, that also would have given me negative 5. So either way you would have done it, whether it was this first way or the second way, they both give you the x value of the vertex. But we still haven't found the final point on the vertex because all we know is the x-coordinate. We know the x-coordinate is somewhere along this vertical line. So what we have to do is we sub that into the equation, and we get the y value of the vertex is going to be equal to negative 5 all squared plus 10 times negative 5 minus 37. And so the y value of the vertex is negative 62, which means that the vertex is going to be located at negative 5 and negative 62. Now, you might see the 62 and think it's related to what's up here. It's not. That is just purely just coincidental in this case. But the negative 5 and negative 62 does mean that we do need a different scale on the y-axis than we have on the x-axis. And that's fine, provided that scale is consistent. So what I'm going to do is I'm going to go down by 10, so negative 10, negative 20, all the way down until we get just over negative 62, which is going to occur at negative 70 there. So negative 70 is as low as I go. Negative 5, negative 62 is right about there. So let's label that as negative 5, negative 62. And now what we can do with those 3 points is we can draw our curve through those. This is actually the parabola that is represented by the equation y equals x squared plus 10x minus 37. And not only have we been able to solve a quadratic using the quadratic formula, but we've now also been able to graph a parabola. This doesn't just apply to whole numbers, it also applies if the coefficients are decimals or fractions. And so in this case, we see that we're solving for x, and we have an a value of 5, we have a b value of 4.5, and we have a c value of 1.0125. Now you'll notice I haven't even tried to common factor this because I look at 1.0125, and that's a tricky number to common factor out, and it's not going to be divisible into 5. So I know that those are going to be the values, and I'm going to substitute this into my quadratic formula. So go ahead and write that general formula out. I always like to write out the general formula first, just so that I don't make any mistakes when I sub things in. So this is negative 4.5 plus or minus the square root of 4.5 squared minus 4 times 5 times c, 1.0125, all divided by 2 times 5. So what I'm going to get here is negative 4.5 plus or minus 4.5 squared is 20.25. But then you're going to notice here it's a negative times a positive times a positive. So what this means is I'm going to subtract 4 times 5 times 1.0125. Well, that is also 20.25. And so what we're going to get under the square root is we're ultimately going to get something minus itself, which is 0. So x equals negative 4.5 plus or minus the square root of 0 is just 0 divided by 10. And so we get negative 4.5. We're not adding or subtracting anything to that. So we're dividing it by 10, which gives me x equals negative 0.45. Now this is a unique situation because there's only one x value. There is only one x value. And so that's the case when we have the b squared minus 4ac value being equal to 0. And so pay attention to what the b squared minus 4ac ends up being equal to, because if it's bigger than 0, as we've seen in all the cases so far, then we're going to be able to add or subtract that value to the negative b. If it is less than 0, though, we run into a situation that we're going to look at in the next example. If you were wondering how this looked on a graph, this is not a y equals equation, but if it had been, and we would set the y value to be 0, what this would mean is it would mean that the x-intercept is the vertex of the parabola. Now to our last example before we look at how the quadratic formula was actually developed. And so what we have here is solve for x. We have x squared minus 2x plus 2 equals 0. And so the a value is going to be 1. The b value is going to be negative 2, and the c value is going to be positive 2. We always try to factor this first. Try to find two numbers that add to negative 2 here and multiply to 2. Well, two numbers that multiply to 2 is just 2 and 1, and if they add to a negative, that means the bigger number has to be negative. That's not going to work. And so this is not factorable, so we have to use the quadratic formula. So we go ahead and we start by writing out the general form, just to make sure that we have that right and don't make any mistakes. And we can then substitute things in really clearly and nicely. So this gives me negative 2. So negative 2 because it's negative b and b is negative 2. And then we add or subtract b squared. So negative 2 squared minus 4 times 1 times 2. All divided by 2 times 1. So x equals positive 2. The double negative makes that positive. Plus or minus the square root of negative 2 squared is 4. But then we have minus 4 times 1 times 2. This is minus 8 all over 2. So x equals 2 plus or minus the square root of negative 4 all over 2. Well, we cannot take the square root of a negative number. And so that means there's no real roots. When you go on in math, you'll learn about complex numbers, but in terms of everything that we are doing at this level, there are no real roots. We have no solution, and that is not going to be helpful. And what that means practically is it means that there are no x-intercepts, that either the vertex is above the x-axis and the parabola opens up, or the vertex is below the x-axis and the parabola opens down. And so that's the real situation that we run into there, but there are no real roots because there would be no x-intercepts. So the one thing we've not dealt with in one of the examples we looked at is what happens if a, b, or c are 0? Well, you would do the same thing. Like, for example, if this said x squared minus 2x equals 0, and the plus 2 at the end wasn't there, you could still use the a and b term, and the c value would just be 0, and you go through the same process with the quadratic formula. Now, in many cases, because you'd have two terms, it would actually be easier to factor it. You could always factor something if it has two terms, or rearrange it to solve it directly. You don't have to use the quadratic formula, but that is always an option. So how do you actually derive the quadratic formula? Where does it come from? Is it just some magic formula that comes out of nowhere? Well, no, it actually comes from something that's very specific. Now, it's important that you know how to complete the square in order to show this. But we're going to start from the ax squared plus bx plus c equals 0 starting point and rearrange this using the completing the square method, which you can find more about in the description of the video if you're interested, and show how this works. So the first thing I want to do by starting from this point is I want to divide everything by a. So I'm going to divide all the terms by a. And I can always divide 0 by a because that's going to still be 0. So I have x squared plus b over a times x plus c over a is equal to 0. And so now what I want to do is I want to create a perfect square with these first two terms. So what I want to do is I want to take a number b over a, I want to divide that by 2 and then square it. And so this is going to give me b over 2a all squared, which is going to be b squared over 4a squared. And so what I'm going to do is, in the method of completing the square, I can just add and subtract that same value to the equation, and that doesn't change anything about the equation. So this becomes x squared plus b over ax. And here's where I'm going to add and subtract those two values. So I'm going to add b squared over 4a squared, and then I'm going to subtract what I've just added. Doesn't change anything, because ultimately that equation is still equal to 0, but that now has the b squared over 4a squared included. Now what I'm going to do is I'm going to bring these two terms, the last two terms, to the other side. So this is going to be x squared plus b over a times x plus b squared over 4a squared is equal to b squared over 4a squared minus c over a. So I've added b squared over 4a squared to both sides to get the negative to come to the other side, and I've subtracted c over a from both sides to get the positive c over a to come to the other side. Now I want a common denominator on the right, so I'm going to multiply by 4a over 4a, and on the left side I'm going to complete the square. In order to complete the square, what I want to do is I want to recognize that I'm going to take the square root of the first term and the square root of the last term, and that is going to be a perfect square because I built that as a perfect square. And so this becomes, on the left side, x plus b over 2a. That's the square root of b squared over 4a squared. And that's all squared. And on the right side, I now have b squared minus 4ac, and they both have common denominators, so that's 4a squared. So it's all over 4a squared. So now what I want to do is I want to take the square root of both sides. In fact, I want to take plus or minus the square root, because anytime, if you had something, for example, like y squared equals 9, and you take the square root, well, it could be positive or negative times the square root, just as a quick example. So you need to always remember to take, when you're solving y squared or something squared equals something else, to take both the positive and negative possible solutions. So this becomes x plus b over 2a, and I take plus or minus the square root of b squared minus 4ac all over 4a squared. And now what we can do is I can say, well, I know what the square root of 4a squared is. That's just 2a. So this becomes plus or minus the square root of b squared minus 4ac all over 2 times a. And then on the other side, I'm left with x plus b over 2a. We are so close now to the final result. I subtract b over 2a from both sides, and I get negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And now I can write that as a common denominator. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is how we get to the quadratic formula. It's an amazing thing that has proven very useful, as we've seen in many examples today. If you want more videos on quadratics and how to graph and how to solve things, how to factor, check out the videos on the screen. Thanks so much for watching. Please consider subscribing, and I hope you have a great day.